So hello, everybody. And today there's going to be a relatively short class. There are going to be one or two things which I'm just going to mention and ask you to do in the exercises. But the exercises themselves, again, are relatively short this week to make up for the lengthy classes that you've had up till now. Okay, so we're going to talk about water today and the issues pertaining to water and its usage on the planet by this already very, very large population of human beings, as well as all the other living things that are on the planet. The first thing to ask is, why is water so important? Why is water so important to life? And the answer is, first of all, life evolved in water, and because all life processes are aqueous, and they all depend on water as a solvent. We are mostly made up of complex solutions of chemicals that interact to give the appearance of what is life. So we are actually aquatic organisms in a way. We are absolutely dependent, as all living things are, on adequate supplies of water in order to remain alive. So our planet is uniquely situated to provide us with liquid water. Most other planets, they're either too far away and all of the water is in the form of ice, or else they're too close to the sun, for example, and all the water is in the form of water vapor. Our planet is different because water exists in all three of its forms, of its molecular form. That is ice, liquid water, and water vapor. And when we look at our planet, as you will in one of the exercises, you will see that there is a water cycle, and water moves between these three different forms, which exist in reservoirs. There are huge stores of ice, there's a huge store of water vapor in the atmosphere, and then there is liquid water in the sea, rivers, etc., etc. And the water cycle, the water moves between these different forms continuously, recycling on the planet. That has worked for many billions of years, but there is a problem, and that is that we are actually damaging those reservoirs. And that is, you'll hear today, some of the problems that associate with the damage that we are causing. So first of all, have a look at the distribution of those different reservoirs and what we can actually use, both in our biology, but also industrially and everything else. All water on the planet, 97% of it is in the oceans, and it is salt water. That's fine. If you're a marine organism, it's not so good for us. We can't drink salt water, and it's very difficult for us to use industrially or any other way. Instead, there is a very small proportion of water on the planet, only 3%, which is fresh. That is, it does not contain sufficient salts to make it unusable. And if we look at the small percentage of fresh water, 3% in total, we see that most of that is in ice caps and in glaciers. There's ice caps at the poles, but also ice caps on mountains and in glaciers, which are moving sheets of ice. The rest, that's about 79%, let's say 80%. The rest, about just under 20%, is liquid water, and that is in the form of groundwater. That is water which is very deep below the surface of the earth. And that is water which is percolated down through the rocks and is eventually ended up saturating the deep layers of sediment and rock. And that is a very, very valuable store of water to us called the groundwater. When it is relatively readily available in the groundwater, we refer to it as being an aquifer. And aquifers can be tapped. We can actually draw water from them. So 20% of fresh water is the groundwater. And then the only 1% only 1% water on the planet, of the fresh water, is easily accessible fresh surface fresh water. That is in streams, rivers, natural lakes, etc., etc. Only 1% is easily accessible surface water. So here's the distribution of easily accessible surface fresh water, but I'm not going to discuss it in detail. So the World Economic Forum, which has just celebrated, by the way, on March 22nd, celebrated World Water Day. The World Economic Forum has every year produces the Global Risk Report, which you can access through this link. And they have identified water as one of the 3 most important challenges that the human population faces worldwide. And this year, they have designated that as the biggest societal and greatest economic risk for the next 10 years. So we have to ask ourselves why this is so. After all, most of us here, we live in the United States. I know not everybody following this class is, but in general, developed countries and in developing countries as well, much of the population, fresh water is relatively easily available. Turn on a tap and you get the water, turn on the faucet, you get to shower, etc. Go to the toilet and flush it, and away the sewage goes. And we don't even really think about water as being a problem. And we have to ask then why experts are looking and saying that it is likely to be such a grave problem in the near future. And here are some facts for us to illustrate why they are so concerned. 703 million people lack access to clean water. They are drawing water which from raw sources such as rivers, untreated, and using it. That's about 1 in 10 of the population are depending on untreated water. The task of gathering water in developing countries especially falls disproportionately on women and on girls. And it takes them away from all sorts of other activities that they could be doing. It means that a family or the group become absolutely dependent on their ability to walk a long distance and to carry a heavy load back and forth, often several times a day, depending on the area that they live in. They may have to walk very far to find water which they can use. Here's a shocking and very startling statistic, and that is more than 1,000 children under the age of 5 die every day from diseases caused by poor water sources, contaminated water, often living in areas where there's poor sanitation. Water sources become polluted with sewage. There may be unsafe hygiene practices, which I'll talk about in a second. But all of these things contribute to providing sources of infection, particularly of diarrheal diseases to children, which remain major, despite all our medical advances, these remain major killers all around the world. So here's another startling statistic. 1.69 billion people live without access to adequate sanitation. Now, that adequate sanitation is most commonly thought of as being waterborne. It doesn't necessarily have to be. It can be that people can use pit latrines, which are far less hygienic than waterborne sewage, but can be managed properly. But in general, we think of the most advanced forms of sanitation as being waterborne sewage, where the water can be taken away and the sewage can be taken away and it can be treated, and ideally be treated in such a way that the water can in fact eventually be recycled, or at least put back into water sources without polluting them. But this becomes very, very difficult in very poor societies. For example, 419 million, nearly 500 million people, practice open defecation. What that means is that they will actually go and defecate, urinate and defecate in the open, in a field or wherever, or directly into a water source. Very commonly, people will go down to a river and use that. And that obviously provides a source of infection for children, etc., etc. If they're defecating in the open field and it rains, for example, the rain will run over this field, will wash the feces away into a water source where they can there, if the person was suffering from any illness or parasitic disease or whatever, the water then becomes a source of infection for other people. So in looking at all of these problems, the United Nations has, through the Paris Accords of environmental agreements, largely concerned with global warming, but setting sustainable development goals for the planet. There's Sustainable Development Goal 6, which you can access through this link here, looks to provide clean water and sanitation to the whole population by 2030. Now that means, you'll see, that means a complete rethinking about many of the aspects of our lives in order for this goal to be achieved. Because currently, worldwide, only about 50% of sewage is adequately treated before discharge. Now that is a huge problem, not only because sewage carries with it the risk of disease and everything else, but because, of course, sewage is extremely rich in organic matter. And when that is discharged into water sources and everything, it can very rapidly result in eutrophication. And in order to remember what eutrophication is, please go back, okay, to our previous classes where we discussed eutrophication to see what it is. The discharge of untreated or poorly treated sewage is a huge problem on many different levels, not only health-wise, but also environmentally. So in further examining this, we realized that there are three areas really where water is of tremendous importance. First of all, human. We've already discussed more than 700 million people lack access to properly treated, healthy, safe water. And about 2 billion access water, which is unsafe, has the potential to be unsafe and dangerous. Now, the difference between these is these are people very often who may be accessing river water, for example, or well water. Their water is much of the time it's relatively safe for them to use, but very easily contaminated. And for a huge number of people actually use water of very doubtful quality. So many people, we would say, are water stressed. They actually have poor access to healthy water, and they are at risk of disease and from the water that they use. We also need water for food and for agriculture, and this is, we'll see in a minute, is one of the major uses of water. The agricultural sector is one of the major users. And the global increase in population and the development of industrial processes, both non-farming and industrial farming, has led to an overuse of existing water resources. And that is especially groundwater, as we'll hear in a while, but also overuse of available water resources, which leads to deprivation of water for for some. If somebody is taking too much water, somebody is not getting enough. Think of it that way. Thirdly, we need water for the environment. All living processes depend upon water, and many of the biomes that we've talked about depend upon a certain level of water. So that each biome that we've discussed previously needs a certain amount of water put in and is adapted to that amount of water. May be adapted to variations, seasonal variations, for example, in the water supply. But overall, in order to maintain their ecological structure, they require a certain amount of water. And if we abstract water on its way to those biomes, we deprive them of water. And this is done in particular by damming, for example, damming of rivers, but also damming them and abstracting water, taking water out of rivers and lakes, for example, to supply either cities or farmland or something like that, without allowing it to be replaced in some way, removing water faster than we can put water back, or the environment can put water back in, leads to a depletion of water further downstream. And this starves living systems like rivers and wetlands and produces a huge range of problems for not only for biomes, but for cities and everything which lie downstream. So one of the huge problems for human beings is the available water is unevenly distributed around the planet. I'm not going to go into this in any great detail, but if we just look at the amount of precipitation that falls on the planet, we know, for example, that in the equatorial regions across here, there's a much, much higher rainfall than there is in the regions which lie just to the other side. Go back to the biomes lecture and remember that in these areas here, we have low pressure areas, atmospheric pressure, and just north and south of them, we have areas which are high atmospheric pressure and are dry. So immediately we see there's a wet band on either side of it. There are dry bands. Well, these areas are not devoid of people, and they are not devoid of flocks. They're not devoid of people needing food. And in other words, some areas have to adapt to a much lower water availability than others. And increasingly, there is a move towards moving water artificially as we would move any other resource. So think of it this way. There are certain areas of the planet, for example, which have a lot of oil, a lot of fossil fuel. And there are other areas of the planet which have very little. What do? We depend on companies to abstract the oil from the ground, process it, and move it to those places that need it, where they sell it. Now, we are not used to thinking about water in that way, but unfortunately, that is something that is increasingly coming into the interest of companies who are beginning to look at these water-rich areas and wondering if they cannot somehow buy the water, get the water, and move it to places that need it and sell it. The era of water as a commodity is beginning to be thought of. And that may, in fact, bring its own problems. Okay, so what are the major threats to our water resources? First of all, as I've mentioned, overuse. Just taking too much water, taking water faster than it can be replaced from whatever resource we're abstracting it from. Second of all, if we look at the way in which we use water, we waste a tremendous amount of water. In some areas, depending on what you're talking about, whether you're talking about home use or industry or whatever, you can think that about between 15 and 20% of the water is actually simply wasted. It's not used efficiently, And in course of wastage, it may be put into a form, it may be polluted, it may be or whatever, and its usefulness is vastly reduced. Pollution is a huge problem. And pollution we're not going to discuss in detail yet, but we think water is often polluted in two ways. The first is that it may be organically polluted, as we've discussed, through sewage, that's through water flowing across animal feedlots, etc., acquiring a huge organic load, and then being put into something like a stream or a lake, or into the sea and causing problems. But the second form of pollution is from chemical pollution, and unfortunately, often that entails polluting water with chemicals which are unnatural, synthetic, and are not processed easily by the environment. The fourth way in threat to our water resources is by us accessing that huge store of fresh water which lies in the groundwater. And overuse of groundwater depletion, is leading to a number of very serious problems. And there is a reading for you in the exercises which I'd like you to do. But the one problem that we see when we take out too much groundwater, we've said in another lecture, is that in fact the ground begins to subside. The groundwater lies very deep, but it acts as a support, as a foundation for the sediments above it. Abstract the groundwater too much, abstract it faster than it can be replaced, and what will happen is the ground will begin to sink. But the second and really important problem for agriculture is that these very deep groundwater stores, the aquifers which lie very deep, very often underneath them have a layer of salt water, which has come in from the sea. It can go very, very far inland in these deep sediment layers. And if we take out the groundwater, it begins to be replaced by salt water. And here is in the background here is an example of a field in North Carolina where that has happened. This white here is not soil, it's actually salt, which is precipitated as the water evaporated from the surface. And these fields are useless. And this requires a huge amount of water then to be either to fall as a form of rain or to be put onto it to wash out the salt before the soil can be reused. So the problem that we face is twofold. The first is that we know that our population has been increasing exponentially for a number of years. We've been adding about 1 billion people every 12 years for a number of decades. So if we look for, we're just going to look at this in terms of units, okay? We're going to start off 1900, there were 1.5 units of human beings. That reflection of the fact that there were about 1.5 billion people in 1900. Now we move to here is a unit. These are, just think of them as units. Okay, 1.5 units of water that these are using. So we move to 2000, and we find that we now we have 6 billion people on the planet. We've quadrupled the number of people. But look at how much water is being used. We haven't quadrupled the water usage. We've doubled the quadrupling. We're using 8 times the amount. Projected forward to 2050, what do we have? Well, we're going to have about between 9 and 10 billion people on the planet. And we are going to be using 18 units of water. You see that the water demand for water is outstripping the population increase. It's that the 18 units, that is 12 times. So we went 8 times, now 12 times. And remember, however, that by 2100, we will stabilize 11, 12 billion, somewhere around there. But our water usage at that stage, the projected water usage, will also somewhat have stabilized, but will still be extremely high. So what is it that is driving the fact that water is increasing, water usage increasing so much faster, the rate of water usage is increasing so much faster than the actual population increase? And of course, the answer is that we, in addition to the increase in population, the population itself is demanding more. So the population is demanding more industrially. Industrial development has boomed. And in addition, the processes of farming, of producing food for this burgeoning population, that has also become industrial. And all of those farming practices that we talked about before, the monoculture, intensive agriculture, intensive use of agricultural land, all of those things demand more and more and more water. So here is the graph of water usage. Here we are, we're starting off in 1900 as we did before. And you'll see that from about 1950, which is the key year for many of these processes, because this is when globalization and global industrialization began, the demands for water have increased exponentially. We do, however, expect them to tail off. And by 2100, they will have, the demand will pretty much have stabilized. But nonetheless, just look at what it is. And it's enormous. And can we get more water? Can we get more water onto our planet? No. We have to work with whatever water we have been given. And so this is the huge problem, is that we have to be able to manage the amount of water that we've been given in a way that is sustainable, that we are not losing water faster than we can replace it. And what I mean by losing water is I mean taking water and making it unusable. And that is unfortunately what is happening to at least some of the store of water that we have. So let's have a look and see where we use the most water. And the first thing that leaps up at us is that most water is used in agriculture. And that is of course, the two forms of usage. The first is direct, that is feeding, that is giving water to livestock, giving water to crops, and allowing them to have enough water to survive, etc., etc. That is one set of demands. But the other set of demands that agriculture places on the water stocks is that a huge amount of water is used in the production of food, for example, for livestock. And second of all, a lot of water is used in processing and packaging of agricultural products. So all of that adds up to the agriculture using by far the most water of any other sector of human endeavor. In you don't need to pay over much attention to the differences between these. This is an earlier year. This is 2020. We're of course 24 years later, but we'll just use this as our basis. Say agriculture, about 48 to 50% of the water usage goes to agriculture. Energy production uses a lot of water as well, nearly 11%. And Industry, a huge amount as well, close to 35%. And the rest is what we use. It says here drinking, but that would be other human usage in general. But this is the really important thing to notice. First of all, agriculture, and then industry, utilization of water. If we just look at the household, there are some quite shocking things to note. Household usage is not the greatest usage of water. Agriculture is by far, but nonetheless, households do use a tremendous amount of water. And if you look at this is for a developed country such as the United States. If we look at a house that has a garden, a lot of their water usage is actually to the garden. And unfortunately, especially in the United States, this is to lawns, to those lovely squares of green grass that grow outside, that people are so proud of and keep for their neighbors. That will use up to 59% of the household water usage will go to that. When we go through, if we ignore the garden, if we just go to the rest of the household usage, the most important thing to note is that the running water toilet uses 11%. And I might add that this is a regular usage. That's the normal flushing. And in fact, this may be much higher if this toilet leaks, which many toilets do. And the second most important is the clothes washer. These I must tell you, these are all normal. These are systems which would have been bought, within the last 10 years or so. But these have no special feature, environmental, ecological features to them. Clothes washers use a lot of water. Showers use a lot of water. But look here, this is just general waste. This is leakage from the system. This is leaky pipes. Maybe they'd included leaky toilets, but households use a tremendous amount of water just by leakage. These can all be reduced if you use high-tech devices, which are deliberately constructed to reduce water usage. I would point out to you, many people think that using a shower is environmentally more friendly than using a bath. Actually, it's not. In terms of water usage, it's not. You use much more water in the shower than you do in the bath. Baths use much less water overall. But the one device in your household which is incredibly efficient and which should always be used is the dishwasher. The dishwasher is a very efficient, water efficient device, far more efficient than washing by hand. You use far more water for washing by hand than you ever would with the dishwasher. So that's just a word to the wise. So all of these demands on the water systems produce a tremendous stress on the actual sources, the water sources. And this is most clearly seen in the stress on river basins, on rivers and on river basins. And this can be for various reasons. What I mean by that is we need to think of two things. We need to think, first of all, on the size of the population. And then we have to think about the amount of water that those river basins actually contain. So, for example, here in India and those areas in Asia, they may actually have, not all of them do by any means, but so these areas may have perfectly reasonable rainfall and everything else. They may have huge rivers, but they also have immense populations, very big populations, which are placing demands on those water sources. So that is how those river basins come under stress. In other areas like Southern Africa, for example, there is not as big a population as in Asia, but still a relatively large population. In this case, it's about, in this whole area here, about 75 million people, but this is an area with very low rainfall. So these rivers are already not huge rivers like you have in Asia, and even the smaller population can produce high demand on what water is available. And you will notice that one of the areas where rivers are coming under enormous stress is in the United States and Central America. There's no better illustration of this than the use of the Colorado River, which is one of the world's great rivers, but by the time it reaches its end point in the Gulf, then it has actually lost almost all of its water. All of its water is abstracted through dams, etc., and is used either to feed huge cities like Los Angeles, whatever, but also to feed huge agricultural endeavors. And by the time it reaches its end, over here, it's practically dry. So, having said that agriculture is such a huge places such a huge demand on water resources, we realize that one of the reasons for that is more and more people demand more and more food, and they demand foods which may actually be high water demand themselves. Now, I've just taken out 4 of these foods to show you as an illustration, but there is actually an exercise for you to calculate the water print of the food that you eat. And you can look up water print for all sorts of different kinds of foods. So let's have a look here with lentils, which are very high protein and also a source of carbohydrates. So they're pretty much a complete food. If we say 4 ounces, 57 gallons of water has to be used to produce a 4-ounce serving. Rice, about 73 gallons per serving, 4 ounces. Now we get to the animal products. Butter, 167 gallons of water per 4-ounce serving. Something like beef, mutton, any of these high quality meats, 463 gallons per serving. And remember that this here, the water is used to provide water for the animal. That's number 1. Water is used to wash out stables, to wash out whatever. The water is used to produce the feed, which is given to cattle in order to feed them up so that they produce the abundant steak. All of these things add up. The meat itself, at the slaughterhouse uses an enormous amount of water for hygiene and cleanliness, washing out blood, etc., the whole time. All of that has to be taken into account. And though that is one of the reasons that this here is nearly 8 times the demand that we used for the lentils. There is an exercise for you to perform, looking at a simple meal and asking you how much water that would actually demand. And you can work out your own as well. So I have the demands of agriculture. Their first source of water in agriculture is rainfall. It's simple. Very often they have a dependence on natural rainfall as a source of irrigation for their crops. The second source of water would be to abstract water from rivers and dams, etc., in the form of irrigation. The third, which is increasingly has to be resorted to because the other sources, the rivers, etc., are so overused at this point in many areas of the world, is that they come to depend upon groundwater. The groundwater, it lies extremely deep. Groundwater may also, in many parts of the world, in fact, in many parts of the United States, groundwater may be a major source for non-agriculture as well, for industry and domestic use as well. So groundwater lies extremely deep. The water that reaches it is, under natural circumstances, is water which is percolated through the sediments, and that percolation can take hundreds and thousands, even millions of years for it to reach the point, its deepest point, where it saturates the rock or the sediment that it fills to form the aquifer. So this process of percolation is very, very slow. But we can easily access, as long as we can drill deep enough, we can easily access the groundwater. And we can pump out high quality water to the surface and use it for irrigation or whatever. But if you think about it, we can pump out very fast. But this process is very slow, even if flood irrigation is used, even if the water begins to percolate from the farm fields, etc. This takes an enormously long time. We cannot replace the groundwater as fast as we take it out. In addition, there's another loss from the groundwater, and that is it slowly percolates down and percolates out to rivers and even percolates out to the sea. So there is a natural percolation, but that percolation is so slow that this is about the same speed. It is our abstraction of the groundwater by mechanical means that depletes it faster than it can be replaced, and that has major consequences. All of these here are major aquifers in the United States, and this map, I'm not going to go into any detail, but you can just see the color. The color shows you those aquifers which are now under threat, which are now stressed by the amount of water that we are removing from them. And you can see that it's most of them. This is the Ogallala aquifer here, one of the great aquifers in North America. This is the Central Valley of California, and this Mississippi Valley, and you can see that most of this water would have been derived from the Mississippi, but it has been taken out largely for agriculture, but also to supply water to cities as well. There's another thing that happens with water used in agriculture, and that is that it acquires a tremendous amount of pollution. It can acquire a tremendous amount of pollution. And this is in the two forms that I've already mentioned. First of all, it's organic pollution from cattle feces or livestock feces, etc. And that's the one thing. But the other is that the water leaving farmland is often polluted with fertilizers, as we have discussed before, with nitrogen and with phosphorus. This is just looking at nitrogen effluents, and this is a prediction of the amount of pollution, of nitrogen pollution, which you can see is increasing in every single sector, in every single part of the world. It is actually increasing and is predicted to increase going forward to as far as 2050. So this is another huge problem that has to be dealt with if our use of water is to be sustainable. We cannot pollute it in this fashion and then put it back into the environment and not expect that there will be problems. So the 2024 World Water Development Report, this is another branch of the United Nations, says that where 2.2 billion people currently don't have access to safely managed drinking water. Worldwide, populations are also beginning to suffer direct water stress. That is, the amount of fresh water available to them is beginning to become limited. And we have seen this in particular in Southern Africa. Now, you remember I showed you that water sources, the rivers and river catchment areas in Southern Africa are coming under tremendous stress as the burgeoning population abstracts too much water from those sources. And this actually not only restricts the amount of water available for agriculture, et cetera, but it makes the availability of water extremely precarious. In the event of climate change of any sort, not only global climate change, but these areas are subject to drought, for example, the entire population can come under threat of loss of their water resources. There is no water for them to use. And this is a terrifying prospect. It is currently being felt very strongly in Johannesburg, which is the largest city in South Africa. And here in the background here, I'll show you a picture. They are having to truck water in from other areas of South Africa, which have more water, but they're having to truck water into Johannesburg and its environments because they simply cannot supply, the water supply can no longer provide for the population. And ultimately, this can lead to a collapse of the whole water system and the collapse of the infrastructure of the water system, which is even more dangerous. Now, in Southern Africa, we had one very, very close call of this already. I'm sorry, this is the wrong date. I'll change it. This should be 2021. From 2017 until 2021 in the Cape, there was a very, very profound drought. This is the major reservoir that supplies Cape Town. It was completely and absolutely bone dry. And they came within days of 3 million people being utterly deprived of fresh water, of having no fresh water available to them at all. Fortunately, the drought broke just in time, and but it was a real object lesson to the city that they needed to improve their water usage and also to improve their infrastructure in order to use the water that they had better and to conserve it better. So this issue is really important, and it's important from a personal point of view. Every one of us should be thinking about this, to a household point of view, to a city and communal point of view, and then to a global point of view. We have to think about our water usage very, very carefully because water is a limiting element for us. You cannot survive without water. And it is reaching the point where these water sources are becoming stressed in parts of the world where we would never before have dreamt that they would be. So I'm not going to go into this in any detail, but I will just point out that technology is one of the solutions that we might turn to. And just on your own, have a look through this diagram, which shows you what the difference between using technologies and things like the bath, the shower, the toilet, dishwasher, etc., which were not designed for water conservation, and those which are designed for water conservation. The average household, and thus a city, a town or a city or whatever, can conserve a huge amount of water just by using water efficient technologies. But that's not only that. An individual household can improve things by fixing leaks, by getting rid of their lawns, which are a huge drain on water supplies throughout the country, replacing them with water-wise plants, with drought-resistant plants, with native plants, which are adapted to the normal rainfall without having to be irrigated. By changing our own habits, for example, although it may sound unhygienic, not flushing the toilet when you urinate. You don't have to flush the toilet when you urinate. The adage goes, if it's yellow, let it mellow, and if it's brown, flush it down. And it's a very good adage because it saves an enormous amount of water. Lastly of all, we would all do well to establish gray water use, using water, let's say from dishwashing, from the shower, from ordinary washing, etc., and using that to irrigate our gardens. And it can even be used to irrigate farm fields, and that sort of thing. Agricultural use, we can improve agricultural use prodigiously by having efficient irrigation, by not wasting water, by not spraying in such a way that we lose most of the water to evaporation and not to serving the plants that we're spraying it on. But farms should be switched to mixed crops, not the monocultures that we discussed before. And this is particularly important because one of the ways to conserve water is to improve soil quality, to improve the ability of soils to store water so that you do not have to water so much. You don't have to irrigate so much. Lastly, on this topic of agriculture, would be to substantially reduce our dependence on livestock, on our dependence on meat in our diet. It's not to say I'm not telling people to eliminate it completely. Certainly can if you wish to become vegetarian, but to reduce our dependence on livestock, on meat, and on the products that animals produce would substantially reduce our demands on our water sources. And in general, the first thing is to educate people about the importance of water to our lives, and to make people aware of the fact that we are using far too much water and we are using it foolishly. We are destroying our water sources, and we need to actually conserve them because our demand for water is going to increase even though our population will stabilize by 2100. Our demands for water are still increasing. And on this note, I'll point out, this in the background here is a lawn. This is in Las Vegas. And Las Vegas is desert country. And look at the lawn and garden. This could be in the Northeast or somewhere. And that is exactly what these foolish people are trying to do. They're trying to create the ideal Northeastern home in a biome where it is totally unsuitable. And in order to do so, they have to use an enormous amount of water. And this kind of self-indulgence has to stop if we're to survive the water crises that face us. And to do that, we've got to educate people. So please make sure that you do all the exercises that I've set for you, because that's going to give you a lot of ways to tell people why they should reduce their water usage, why they should do the things that you're advising them to do. Okay, so thanks, and I will see you again next week. Don't forget that this weekend is the Easter weekend. So happy Easter to everybody who's celebrating, and also Ramadan Kareem to all of those who are fasting. And I'll see you next week.